Hello friends, today I am going to share with you the process of yield improvement in stamping process. So that is the process of creating the value in sheet metal part manufacturing. As you know, we have to make various type of stamping parts in car body making. So generally the raw material is being pressed 4 to 5 times to make a final product which is to be fitted to make the car body, like side body, door outers, hood inner, back door inner, or fenders. So these are some of the examples of important sheet metal parts. So dear friend, you might be aware through stamping process we are generating a large volume of scrap. Around 70% of the byproducts which are generated in car manufacturing company as a whole are iron scraps, and out of which 80% of the scrap in total scrap that is from stamping process only. So if we improve yield to 70%, that can reduce emission as well as material cost to the company by 26% and 24% respectively. So in other words, we can say half of the steel scrap generated in car manufacturing from the stamping process only. So if we reduce the loss of yield, or in other words, if we improve the yield in sheet metal part manufacturing process, we can provide both environment as well as financial benefit substantially. So if you see this part, there is a green color area that may be the shape of the blank, and the finished product you can see after the 3-4 operation we get the finished part like this. So dear friend, in the process of yield improvement, to understand what is yield, so we can mathematically calculate the yield as a ratio of output weight divided by input weight. So output weight is the final weight of the product, or we can say the weight of the finished part, and input weight may be the coil or the weight of the blank. So we start with the coil or a strip or a individual blank as the input. We do various stamping process. During this various process like draw operation or forming operation, then we go for trimming and piercing. So we generate the scrap in this process, and this is the final product we get as the output. So in stamping process there are various type of scrap generated at various operation or various stages in stamping process. Like we have rejected coil scrap, we have rejected blank scrap, we have blanking flat scrap, we have blanking trimming scrap, we have rejected panel, finished panel or WIP panel, we have stamping flats, and we have stamping trim scrap. So dear friend, we can summarize different type of scrap in different category, like coil ID scrap, coil OD scrap, coil and scrap. So they comes under the category of flat scrap. Now come to the blanking scrap. So in blanking scrap we get some flat pieces in the form of scrap, and some trimming operation also carried out if we are using the blanking dies. Then we get the unpainted panels and as a scrap which get rejected during the stamping or during the handling due to damages, and another is we get the scrap of trimming and piercing. It may be in the shape of flat, and as well as they might have the 3D shape also. So dear friend, if we try to understand yield losses, they are almost 40%, 44% of sheet metal used in production of the vehicles. So if we reduce the input weight, in other way I can say, if we simplified the blank in such a way so that my scrap generation should be minimal. Like if I improve the design of the part to simplify the blank shape, or if I improve the blank holder and addendum surface. Sometime addendum we call it in layman language draw depth. So my dear friend, if we are not designing a part properly, if we are not considering the part design effect on the yield, so yield losses may increase due to part design and the requirement during the manufacturing of the part, or we can say in other words in the stamping process. So dear friend, there are different strategies being followed to reduce the input weight. So some of these strategies are very simple, easy to implement, and we can get long-term implementation of yield improvement strategy. So as well as short-term as well as long-term improvement process or strategy can be used to reduce the consumption of sheet metal in automotive car industry, and this is applicable to every industry, even in white goods also, in anywhere. Normally there are 6 techniques which are used to reduce the input weight, or in other way we can say the blank size. Number one is changing the blank shape, size and profile. Other one is changing the profile of the blank. Another technique is modifying the bead design, shape and size of bead, modifying the die face, modifying the punch profile, and using the open draw technique. Instead of using a closed draw operation, can be used a open draw technique. So there are 6 techniques which are used to reduce the input weight, to improve the yield. So I'm sharing you on a layman example for better understanding how to improve the product design to improve the yield. Suppose in this example you can see there is a lever. The prime function of the lever, this lever, is to open a valve. So we have the existing design of this lever, valve opening lever. So blank shape will be like this as shown in the picture. So dear friend, if we are making blanks from this strip, so this will be the configuration of scrap. But if we change the design of the handle or is this lever, you can see the modified shape. So my blank shape is going to be changed. Now it is a tapered blank. However, earlier it was a rectangular blank. So when we go with the same strip, so what is the benefit? I have more scrap available with me. So this scrap can be sold. I can get a substantial amount by selling the scrap. So I can reduce the raw material cost because I am getting money when I am disposing the scrap. But the next thing is which we can do, if we change the blanking die, if we modify the blanking tool also, then I can save this much of material. So dear friend, here is one simple example. By changing the product design, lot of material can be saved. So this is the amount of raw material saving. So I am sharing some more example with you. So if you see here, blank size has been reduced. So earlier, before the improvement, the width of the blank was 1500 millimeter. Now, by doing some adjustment in the draw die, width of the blank reduced from 1500 to 1480 mm. Here is one typical example of fender design improvement. So in the before condition, as per the original design, requirement of the blank size was 1125 by 950. Coil width will be 950. But if you see the A point and B point, at A point and B point, fender design modified. So as per modified data, now coil width reduced from 950 to 894 and the length of the blank reduced, maximum size reduced from 1125 to 1065. So earlier, initially before modification, yield was 48%, but after doing this design modification in the part, product design modification, final yield was 54.5% and there was cost saving of 16.8 million rupees from this particular part to the company. There is another concept, triple action die. Wherever we have draw depth more and more, where we can use triple action dies. So when we go with the triple action die, we need less addendum for welding because we have lower half blank holder as the floating as well as we have upper blank holder also. So in the before condition, the yield was 60% when we were using the single action draw die, but with the use of triple action draw die, yield improved to 67% and there was the cost saving of 15 million rupees for making this particular part. So dear friend, if you found the video useful, do not forget to like the video. If you want to know more about various tools, technique, system used to improve the productivity in automotive industry or in manufacturing sector, you can subscribe to my YouTube channel which is in the name of Ashish Agarwal Corporate Trainer. Thank you very much.